All right, in this video, I'm going over number 7 from the non-calculator, paper 1. So we have f of x equals m minus 1 over x, and then we have the line y equals x minus m intersecting that graph in 2 distinct points. So that 2 distinct points is a clue here that I'm going to have to deal with the discriminant somewhere in this question, but I don't have a quadratic equation yet, so I'm just going to leave that over on the side and see if I can use it later. At the beginning, I know that these two things are intersecting, so I'm going to set them equal to each other. Since this is non-calculator and I don't have enough information in each of these equations to actually graph these functions and see where they intersect, I'm going to set them equal. The very next step needs to be to, well, I guess you could combine the m's first because there's an m on each side of this equation. So I could add m to both sides and get 2m minus 1 over x equals x. And now the very next step needs to be to get rid of this denominator x. I need to get these x's together somehow, and I want to get rid of this fraction where x is in the denominator. So in order to do that, I want to distribute x through both sides of this equation. So if I distribute x on both sides of this equation, I end up with 2mx minus 1 equals x squared. And now I have all x's out of the denominator, and if I rearrange this thing to standard form, I'll see that I have a quadratic. The problem with this quadratic is that I don't have the b value, right, because there's an m in there. But I know that I'm looking for a specific m value where I have 2 distinct solutions. So 2 distinct solutions means that the discriminant must be greater than 0. And I can set up a discriminant equation for this because the discriminant, which is b squared minus 4ac, will not have x in it anymore, and therefore the only variable that will remain is this m that I have, and that's what I have to solve for. So the a value is 1, the b value is this negative 2m, and then the c value is 1. So the discriminant is b squared. I'll set up negative 2m squared. Notice that the negative 2m is in parentheses as the b value, minus 4 times a times c. A and c are both 1, and I need to set this up being greater than 0 in order to solve for the values of m. Negative 2m squared is negative 2 times negative 2, which is 4m squared, minus 4 is greater than 0. 4m squared is greater than 4. M squared is greater than 1. This is a quadratic inequality that I can solve by square roots, as long as I remember that when I do the positive square root, I keep the sign, and when I do the negative square root, I flip the sign. And these are the possible values for m that would give us 2 distinct solutions when these functions intersect. And that's all.